Let's look at finding the derivative of a rational function. Now, we will discover something called the quotient rule that allows us to do this as well, but I think a really good strategy for dealing with finding the derivative of rationals is trying to simplify first if possible. So we have f of x is equal to negative 2x cubed plus 4x squared, and each of these components is being divided by 2x. The 2's cancel for that first piece, leaving me with a negative 1. X to the cube, take away an x, gives me an x squared. 4 divided by 2 gives me a 2 here. X squared taking away an x leaves me with x. So my function f of x is equal to negative x squared plus 2. If I want to find the derivative of this, I can use the power rule. Power rule says I can drop exponents, so this 2 exponent comes down. That becomes a negative 2x. And I drop 1 from the power, so I used to have a power of 2. Now I have a power of 1. So essentially, it's taking away one of the x's. For this next one, 2x to the first, if I bring down the 1, I have 2 times 1, or 2. If I take away my only x there, that's just going to leave me with the number 2, because x to the 0 is 1. So the derivative of negative x squared is negative 2x. The derivative of 2x is 2. So the derivative function for f of x equals negative 2x cubed plus 4x squared all over 2x simplifies really nicely. It becomes the derivative of x is equal to negative 2x plus 2. Of course, this is assuming x does not equal 0, because our function was undefined at x equals 0. We would have been dividing by 0, and we can't do that. So that's how you can find the derivative of some of these rational functions. Try simplifying them first. You might not have to use something as messy as the quotient rule. You might be able to just use direct application of the product rule or of the power rule.